Division question 4. Let's have a look at it. Well, here we have an exponential graph. G of x being equal to a to the power x. And we have a point S with x coordinate 2 and y coordinate 9, which lies on G. T being the y-intercept of G, which is right over there. Write down the coordinates of T. Well, as we know, in any standard exponential form, unless they have put a modifier in front, we know that it's equal to 1. But we also know that this is equal to 0. The x value over here of t. So a to the power 0 is equal to 1. Therefore, t has coordinates 0 and 1. And then for 5.2, we need to calculate the value of a. Well, we do have a set of coordinates to facilitate that process, because that 2 and 9 tells us that f of 2 is equal to 9, with 9 being the y value. So 9 is equal to a to the power 2. You can rewrite 9 as 3 squared being equal to a squared on the other side, of course. And because our exponents are identical, we know that the bases are identical. So a is equal to 3 as requested. Well, let's get out g of x back. So that's just going to be 3 to the power x. The graph of h is obtained by reflecting g in the y-axis. So g is being reflected in the y-axis. So what does that do? Well, it does that. If we take this point, it stays there. Take some other imaginary point, that gets reflected over there. But they want us to write down the equation of h. So as we can see, only the x values are affected. So h of x is equal to g of negative x. And that's just equal to 3 to the power negative x, of course. And just for funsies, it'll look like that, because it's a reflection in the y-axis. Write down the values of x for which log 3 of x is greater than 0 and less than 1. Well, log 3 of x, log base 3 of x, is basically obtained by doing this. What is this? Well, it's obtaining the inverse, and the inverse is going to do that. So what do they want? Well, we know that's going to be 1 and 0, because that's 0 and 1, and our coordinates just swap places. So the values of x for which log 3, this graph, is between 0 and 1, is from here to there in the y direction. So we need the coordinate over there, and then if we place that, log 3 of 1 is just going to be equal to, where does that happen? Well, log 3, so these are the y values that need to be obtained, but between which x values does that happen? Well, as we can see over here, that would happen right over there. So what they actually want is where the inverse exists between 0 and 1, but they want the x values for that. Now via symmetry we'll be able to see that the y values on the inverse for that is basically between 1 and 3. So if we take that across, it'll happen on the x-axis. Now what do I mean over here? Well, between 1 and 3 on the graph of f, now, we know that those x values are 0 and 1, because 3 to the power 0 is equal to 1 and 3 to the power 1 is equal to 3. But it's these exponents now become the y values over here for our log. So everything inverts to being between 1 and 3, which is what this question is asking. Remember, this is h of, not h of x, this is actually the inverse of g. So for that, x is greater than 1 and it's also less than 3. Well, that's it, apparently.